Alright, so yeah, this is the demonstration for the sockets API that I've been developing here for NAT traversal. So just first of all, to prove that I am indeed behind network address translation here and showing that what I have done actually works, I'm just going to open up a command prompt and let's do an ipconfig. And see, alright, my wireless adapter, my IPv4 address is 10.0.0.4. Let's open a new window and let's get my IP address. Right, 98.229.223.9. Okay, yeah, so obviously that is different from what this is showing. Great. So now that we've established that there is a problem to be solved here, let's solve it. So here is a just kind of an SSH session into an Amazon EC2 machine that I'm currently, virtual machine that I'm currently running. It's not behind a NAT because the server, it's running a server, and the server cannot be behind NAT. So the server kind of has like a master node and then a bunch of other nodes, and the master node is used for kind of updating the communal routing table. I mean, one thing that could be done is to use a real gateway protocol, instead of having this one little master list here contained within the server. Currently, the server is just a bunch of threads, right? They're not separate processes. The idea is that you have this thread pool, and all those could be pulled as separate processes, and then you don't have to have them talk to the server anymore because you have your routing tables distributed amongst them. In any case, that's getting a bit ahead of ourselves. Now, let me just show you that this is working. So what we're going to do is I'm going to connect to myself. So we're going to start a listener over here that's going to connect to the server. Then the server is going to register that, all that. We're going to connect a sender, and sender's going to connect the server register it, and then the sender is going to attempt to send data to the receiver, or in our case the sender and the listener. So first of all, let's start up the server. Now, let's say you don't really know how to use this. Just put in a bunch of stuff. Oh, there we go. Okay, so let's do that. So I've been using port 9119, no particular reason, just kind of picked it. And let's do 50 threads, doesn't matter whatever you want to use. Great, our threads have started, and we're bound to 0000, and that's actually because we want to listen on all interfaces. We're listening for a very particular message, so it shouldn't be a concern. The idea is that you don't want to have to be doing configuration. We're trying to get this as close to zero configuration as possible, right? So that's the reason for that, right? So anything that comes in at port 9119, it will try to pick it up. It will interpret it to see whether or not it was actually a valid request, and if so, it will respond to it appropriately. And if not, it won't. So we have the server started. Now let's start the receiver. So here's the receiver. Okay, so because we actually have to go here anyway, I'll show you what the arguments to that were. It's just the IP address and port of the proxy server, the non-netted kind of middleman between the two hosts that are trying to connect. So that's just the IP address of this machine here, and the port. So what we have to do right now is we already have the server's IP address and port, and let's just put in the IP address and port that we're trying to send to. So it's 98.229.223.9 and port 51278. Great. So we'll apply that, and now let's run it. Boom! Oh look, I think it worked. Great. Actually, it did work. It always works, but yeah, here we go. So we have the listener and the receiver and the sender, right? So the sender, first of all, connected to the server, which is this server IP address, and then it connected to the other client with the IP address and port that you specified as arguments to it. In the constructor really. So let's pop over, because actually this main thing is we're not directly running a program. This is a tester, so what it's doing is just creating a new client instance. In this case we're giving it 4 arguments, so it creates a new client object. Instantiates a new client object given your 4 input parameters. Anyway, so that works. So now let's go to the receiver. Hey, look, we received the hello again other user payload, right? Right here. This is just kind of for debugging to show that because what has to happen is that the main of the client, you kind of have 2 threads at all times on the client side. You have kind of like a main thread that is connected to the server and is receiving data, And then you have like a kind of a subthread of that, and that's either a sender or receiver, and that is it shares that same the same stream that is connected, so that you only have one connection to the server. You don't create a new connection to the server just because you spawn a new thread. That's the idea. So yeah, it just shares that. That's why you have two. This just kind of forward, so you can see what's going on. To make sure if it gets to here, but then doesn't get to here, you know something's funky. But that hasn't really happened yet. Anyway, look both ways before crossing a one-way street. So now let's go over the protocol here. We have the read from client connect, and then receive connect message, and read from another thread connect and receive connect message. You'll see you actually only have two threads here that are communicating, thread 10 and 8. And they're not necessarily, that's not the order they were started in, right? So they start 8 and 10, So there's kind of like it's a bit of a race condition, but it's actually fine, because you have these stateless threads, and whichever one gets the client gets the client. We have we have kind of like a monitor going on here in prod-con structures or prod-cons utils, and the idea is that you have kind of a it's an explicit monitor, really. You have a bunch of threads that are waiting on a condition variable. Condition variable signals, one of them wakes up, is able to access shared data, and the shared data in this case is just all the clients that are trying to connect. But we'll get into more detail on that later. So the client sends a connect message to the server. Now the server, what happens is there's a thread assigned to each client, one thread to one client, right? Server realizes, okay, I got a connect message, and then it parses this whole part here, and it sees the source and destination. It says, okay, wait a minute. So I know I'm connected to this IP address in this port. In our case, the server thread 10, which is handling the sender, knows that it's currently handling this IP address and this port, right? So it realizes that, okay, this is the destination, this is the source, because the connector message always has the destination IP address and port, and the destination in the source IP address and port. It goes, okay, this isn't me, so it does a lookup on the server, on the kind of like the main server, which is doing the gateway protocol, aka having a map of IP address, and IP address and port tuples. In our case, it's a net socket address. To streams, which represent the other clients, which streams could basically it's like a thin layer of a file descriptor, so it could just as easily be a mapping to the IP address and port of other processes that are being used in the cloud here. As server side kind of super nodes. In any case, so receives a connect message. So it actually sent it to server side 8. You'll see that because it goes, okay, I'm handling port 51729 and 98.229.223.9. That's this is not my this isn't who I'm handling. So you look up the input stream of the thread that does handle this, which is server thread 8, and then send it to them. Server thread 8 looks at this and goes, oh, wait a minute, this is me, right? So it has a connected client, which has this IP address and port, and then it just forwards this message, this whole message here to the actual client, So, and this is just this is asynchronously kind of put out. I mean, it's streams, and it's multi-thread programs. So it's not like it received two connect messages. This receive connect message just means that it recognized this kind of the stream, the string, as containing a connect message, right? So this is actually for this. In any case, now, so it forwards this to the client. The client responds and sends back to its thread in the server a connect accept message, right? And the IP address and ports are the same, it's just that they're actually interpreted in reverse. So what was previously, the source IP and port is now the destination IP and port, and vice versa. So you just route it the exact opposite way as you did the connect, which makes sense because you want to give that connect accept back to the same, client, the same other host that did the connect message. So you just do that. As you see 8, it parses this and realizes, wait a minute, I'm not handling the thread that I'm trying to send this message to. So it looks up which, the stream of the thread that is handling that, which happens to be server thread 10. It forwards that message to server thread 10. 10 goes, okay, this is me. I'm connected to the client, or the host that's represented, the host that was constructed with this IP address and port, and then it forwards it to the client, to its connected client. So this is a server thread forwarding to a user, like me, right? So it forwards that, and that means the sender, once it receives a connect accept message, knows, okay, it's clear to send, it works, that host exists. If it sends a connect request and there isn't a host there, it actually echoes it back to the sender, and that shows that it does not exist. So if the lookup fails and that the host that you're trying to send to doesn't exist, it just sends that connect request back at you, and that's how that there's nothing there. Anyway, so since there's a successful connect accept, it now sends data, the data message, right? So you have your IP address and port just like before, and then you have your begin data. This is just a signal showing, okay, everything that comes after this is data. So it sends that. So it receives a message, and then it goes, okay, this isn't me. I'm trying to send to the other host. I'm not connected to the host that this message is bound for. So it sends it to server thread 8. Server thread 8 looks it up and goes, okay, this is me. I'm connected to this client, and then sends the data message to the client. And as you'll see right here, the client listener, because this is the actual client, right? So this is all server stuff and this is client stuff, because each client is connected to one thread in the server. So the client received the data, and the payload was hello there again, other user, right? That's the idea, right? Because you created a new sender client, right here, and you said, okay, write this, right? So you could write whatever you want. You could just keep writing stuff, whatever, if you wanted. And you can write directly to you have an input stream, right? Or sorry, actually an output stream, an output stream which pipes to an input stream that you can write to. That's actually in the interface, right? So let's see, we actually have that here. I'll just go over this real quick. Let's see. Yeah, okay. Yeah, so you basically have this. Oh, wait a minute, this is an old one. 1 second. Okay, yeah. So yeah, here it is. You see you have your getters, write functionality and read functionality, so you can actually get the input stream directly and get the output stream. And these write methods are kind of redundant. You don't really need them, I guess. But they're very convenient to use, if you just want to write a string literal or just send some bytes, arbitrary bytes. So yeah, that's how that works. As you've seen, we have traversed that, we have sent a message, and we have received it. So that is the demo.